Good morning, dear students. Welcome back to Target NEET Class 12 Physics. We are in first lesson Electric Charges and Fields. Today our discussion is calculating electric field in different cases. First one, electric field near a conductor. So first, let us discuss about this one, electric field near a conductor. Let us take a non-uniform body like this. So here the radius of curvature of this part is RA and radius of curvature of this part is RB. We know it. More charge will accumulate wherever radius of curvature is less. Less charge will accumulate wherever the radius of curvature is more. So surface charge densities we calculate in this case. What is the surface charge density? Surface charge density formula, charge per area. That is the formula for surface charge density. So here surface charge density is plus rho A. Here this is rho B. What we know is RA is less than RB. That implies sigma A is greater than sigma B. So if more charge is there accumulated in a place, the electric field strength, intensity of electric field is more. So that implies electric field at A is greater than electric field at B. Electric field at A is greater than electric field at B. Why? Less charges are there. So electric field intensity is less. So what is the formula for EA? This formula EA is equal to sigma A by epsilon naught and EB is equal to sigma B by epsilon naught. So here we are not going into the derivations. Those who are preparing for board examination, derivations they have to know. But here, whatever important for our NEET examination, that only we are discussing. These formulae very important. You have to remember, write all the formulae on a page or one paper and daily you go through it so that you can remember at the time of examination. So here we are connected with only formulae and how to apply and how the formulae changes. These things you have to observe. So this is the part A. In part B, charged plate. So I will take a charged plate. So this is a plate. Only single plate is there. So I have charged it. So positive charge is there. The plate is having some area like this. This is a charged plate. So near a charged plate, the electric field direction is this one. So here electric field direction is away from the positive charge. This is the electric field direction. Here electric field direction is away from the positive charge. So here this nearest point P, it is away from the positive charge. So this is the electric field direction. The magnitude of electric field here for a single plate of area A is sigma by 2 epsilon naught. This formula you have to remember. So this is the surface sigma. Then if two plates are there like this, positive, positive, and here another plate is there. So here on this negative charge is there. So at the nearest point, at the midpoint, we say it at midpoint, this is first plate, this is second plate. Electric field direction is, see electric field direction is from positive to negative. This is the direction of electric field. So here positive is there, away from the positive, electric field due to first plate. Second plate, negative is there, towards the negative the electric field comes. This is the direction of electric field because of the plate 2. So both electric fields are acting at a single point, nearest point, middle point. Here you have to remember at middle point. So the electric field, net electric field is equal to E1 plus E2. So E1, E2 both are same. That value for one plate, sigma by 2 epsilon naught. So sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So value is sigma by epsilon naught. Outside the plates, the electric field is equal to 0. Outside the plates, this is outside the plate, the electric field is equal to 0. These are the important points you have to remember. Next, our discussion is uniformly charged wire. So here, first case, let us take a circular arc. So this is a arc. This is the center of the arc O. So this is the radius, and this is also a radius, and this is a perpendicular bisector. So this is also radius. This angle I will take it as theta 1. This angle I will take it as theta 2. So uniform positive charge is there on the surface. So if a uniform positive charge is there, the direction of electric field at O, let us name it here at O. Here the electric field will be along x-axis as well as along y-axis. See, always the electric field is away from the positive charge. This is the x component of the electric field due to this arc, and this is the electric field along y-axis, directed along y-axis. These formulas are very important, you have to remember. So here actually the positive charges are there. So K lambda by R is the radius, into sine theta 1 plus sine theta 2. This is the formula along x-axis. Along y-axis, K lambda by R. Lambda is linear charge density. I'll write cos theta 2 minus cos theta 1. This formula you have to remember. Here, the linear charge density lambda is equal to charge per length. Why? Because along the length of the wire, positive charges are spreaded. In previous examples, charge is spreaded on the area. So aerial charge density, surface charge density we have taken. Here linear charge density we have taken because it is a wire. So next, let us consider semicircular wire. So semicircle I will take. This is a semicircle. This is the diameter, and this is the center. So from the center, this is the radius, this is the radius, this is the radius. The angle here is 180 degrees, we know it. Now what happened? Total uniform positive charge is there. Uniform positive charge. But here, let us divide, because we know the formula for arc only. Here two arcs are there. This is the first arc, second is the second arc. So here this is 90 degrees. So theta 1, theta 2 if I take 45 degrees comes. So y component cos 45 minus cos 45, it will cancel away. So here in this case, what is 0? Y component of electric field is 0. only x component will be existing. What is the x component here? X component. See, x component direction is this one. This is the direction of x component of first arc. Second, this is the direction of electric field due to second one. Both electric fields are x components. Here, this is 45 degrees. This is also 45 degrees. This is also 45 degrees. And this is also 45 degrees. So here, this is 90 degrees. Right? So Ex value k lambda by r, theta 1, theta 2, both are equal and 45. So sine 45 degrees plus sine 45 degrees. Sine 45 is 1 by root 2. So what comes here? K lambda by r into 1 by root 2, 1 by root 2, 2 by root 2. So here root 2 k lambda by r. That is the x component. E1, E2 both are x components, so both values are same. This is root 2 k lambda by r is the radius. This is also same, root 2 k lambda by r. Both vectors are same and angle between them is equal to 90 degrees. Then the resultant electric field, the resultant electric field direction is, this is the direction of resultant electric field away from positive. So first arc, this is the direction of electric field. Second arc, this is the direction of electric field. Y component became 0 in this case. So only x components are there. That is equal to root of E1 square plus E2 square. But what we know? But E1 is equal to E2. So what formula we get? ER is equal to root 2 E. So here root 2 becomes 2. 2 k lambda by R. So these results are very important. You have to remember. Let us move on to next point. Next point. If 3/4 of the circle is there, if 3/4 of circle is there, this is a wire and uniformly charged. This is the center O. Here what happens? The y components will cancel each other and x component, even y component here is equal to 0. The y component in this is 0. Y 45 degrees and 45 degrees. So here this is 1, this is 2 and this is 3. Due to 1, the electric field will be like this. This is due to 1 first arc. Because of this third arc, this is the electric field due to 3. Both electric fields are equal, so they will cancel each other. So we are having only one electric field here. We know that this is 45 degrees and this is 45 degrees. So here the electric field value is E is equal to, this is the direction of electric field. E is equal to root 2 k lambda by R. So this value you have to remember. So E is equal to root 2 k lambda by R. Next, let us take total wire, total circle, uniformly charged, and this is the center, and this is the radius. At the center, E naught is equal to 0. Why? Because no charge is existed inside the circular wire. So electric field is 0. Next, I have taken this one like this. So positively charged, from the center, this is the center O. At x distance, point P is there. At point P, electric field we have to calculate. The radius of this wire, circular wire, is R. Then the formula, what is the direction of electric field here? The electric field direction is away from the positive. So this is like this. This circular wire is kept like this, so perpendicular to the plane of the paper, and this is the direction of electric field. This electric field at point P, direction is this one. So electric field at P directed away from the positive wire, K, Q. So total charge I will take as a capital Q, and x is the distance by x square plus r is the radius of the circular wire, 3 by 2. So this is about circular wire. Let us move on to the next case. Next our discussion is on uniformly charged ring. Let us take first a ring. So this ring is having a thin edge, thickness is very less, and this is positively charged, and ring radius is R, O is the center. So we know that the electric field at the center is 0 for the ring. And next B, we have taken a ring. This is a small rim of the ring, and it is positively charged, uniformly charged. So total charge is Q on the ring, and this is the center of the ring, this is the radius R, this is the center. If what happens, if a small opening is made here on the ring, so small opening is made, this small opening of width A is made, then what is the electric field at the center? So many times this question also came in the exam. So all the points, if you see, because of symmetry, all the electric fields will cancel away, but only whatever the section here just opposite to the opening, this small section of this ring, it is having positive charge. Because of positive charge on this small element, the electric field will be there at O. This is the direction of electric field at O. See, what is the charge here? Small q charge is there. What is the width it is? Its width is A. So our regular formula is electric field is equal to kq by r square. This q value we have to calculate. What is the q value? Q is equal to total charge is q. So total length of the wire is 2 pi r. How much is cut? This small element A. So this is the charge. So this charge value, if you substitute here, you can calculate the electric field. The direction of electric field at the center is away from the positive charge and towards the opening. Next, if ring is inside way like this, so it is uniformly charged. This ring is kept like this, normal to the plane of this board like this. So this is the radius of the ring R. This is the center, this is the radius. From the center at x distance, here some point P is there. At point P, the electric field we have to calculate. What is the electric field here? The direction of electric field is away from this positive charge. The ring is like this. So around the ring, positive charges are there from the center x distance. The electric field here is K Q x by x square plus r square whole power 3 by 2. This formula you have to remember. As usual, electric field at the center is equal to 0 for the ring. Now, one more point here you have to remember is sometimes they will give one pentagon or hexagon, regular pentagon like that. If it is so, see, you imagine a circle. So pentagon is given. So this is a charge Q and this is another charge Q. These are all point charges. This is another charge Q. This is another charge Q plus Q and this is another charge plus Q. 1, 2, 3, 4, 5 charges are there. So if you just join these point charges, you will get a pentagon. So in the problem sometimes they give a pentagon, regular pentagon is there. What is the electric field at the center? What is the electric field at x distance from the pentagon? So as usual, this is the center O. So electric field at the center is equal to 0 as usual. Why? Because charges are uniformly distributed. Because of symmetry, the electric fields due to each charge will be cancelled out. At x distance from here, if pentagon is kept like this, just like this, 90 degrees, at x, point P, the electric field direction is away from the pentagon. So E is equal to, same formula you have to use, K. Here total Q is 1, 2, 3, 4, 5 charges of Q into x by x square plus r square whole power 3 by 2. Like that, if many charges are there, they may give 5 charges, 6 charges, 7 charges, 8 charges, whatever it may be. We take it as a polygon. So n charges are there, n charges like this, and n charges are kept normal to the plane of the paper from the center at x distance. What is the electric field? Like that question also comes in the exam. Then the electric field at P point is equal to, electric field at P point is equal to K. How many charges are there? N charges are there. X by x square plus r square whole power 3 by. This formula you have to remember. Let us move on to the next point. Is variation of electric field along the axis of ring. We take a ring like this, and it is positively charged, uniformly charged. The total charge on it is capital Q, and this is the radius of the ring, and this is the center O. And if you go here along x-axis, x distance, here P, the electric field here at P direction is this one. So electric field direction at P is this one, and formula is K capital Q x by x square plus r square whole power 3 by 2. See, we know when we go away from the charge, the electric field strength decreases. So at infinity, the electric field intensity becomes 0. So what happens here at the center also? At the center also electric field is 0. That means what? Electric field is gradually increasing and it is exponentially decreasing. So it is gradually increasing means it must have a maximum value. So what is the E maximum here? E maximum. For maximum value of E, for maximum value of electric field E, what we know, d by dx is equal to 0. So if you do the d by dx for this equation, you will get x is equal to plus or minus r by root 2. These results are very important for you. Often they ask in the examination. So the maximum value of E will be at plus or minus r root 2. So here, if you draw a graph, so it becomes maximum and then it decreases. It won't accepting the x-axis. Why? Because at infinity it is 0. So it we have to leave a gap here. So this is the maximum value of electric field, and it is plus r by root 2. Here also this is a positive x-axis. If you go backwards, negative x-axis, then here also this will become maximum and then it exponentially decreases. This is the maximum value of electric field. This value is minus r by root 2. So at these 2 points E becomes a maximum. So what is the value of maximum E? So in the place of x we have to write r by root 2. So I will write k, q and r by root 2 I will write here by x square r by root 2 whole square plus r square whole power 3 by 2. So this value if you calculate and simplify, this becomes 2kq by root 27 r square. So these results are very important, and any question comes related to this, you can do it in a lightning speed. Our next discussion is uniformly charged rod. So in this, first we discuss electric field on axial line of a rod. So this is a rod. So rod length is L and it is uniformly charged. So total charge is Q. So on axial line, this is the axial line. I may draw an axial line like this. This is the axial line. On this axial line, a point P is there. That point P is at R distance from one end of a rod. At P, the electric field we have to calculate. The electric field direction is as usual away from the positive charge. That arrow mark shows the direction of electric field. The electric field direction is showing by this one. So the electric field at P is kq by L into 1 by R minus 1 by R plus L. So this is the formula. Next, on equatorial line, this is a conductor, a rod, it is uniformly charged. This is the length of a rod. So total charge given is Q. From the center of the axis, if I draw a perpendicular, then this line is called equatorial line. At point P, we have to calculate the electric field. This point is at r distance from the conductor on the equatorial line of the conductor. So here the direction of electric field is this one, away from the positive charge. This is the electric field direction. The electric field formula 2 kq by r root L square plus 4 R square. So that is the magnitude of electric field on the equatorial line. And at r distance from infinity long rod. So this is the rod. This length is infinite. So uniformly charged positive charge is there. So along the length the charge is spreaded. So the linear charge density is plus lambda. At a distance r, one point P is there. At that point the electric field we have to calculate. The electric field direction is as usual away from the positive charge. This value is 2 k lambda by r. Let us go to the next case. Semi-infinite uniformly charged rod. So semi-infinite. So infinite length it is having, it is uniformly charged. So at one end, at distance r, at point P, we have to calculate the electric field. Here, this is a positive charge. Away from the positive charge, this is the y component of electric field parallel to this one. This is the x component of electric field, and this is the resultant electric field. This is 45 degrees. Don't forget this one. In this case, Ex is equal to Ey, that is k lambda by r. Both are equal, so E is equal to, and angle between them is 90 degrees. So this is Ex square plus Ey square, that is equal to root 2 k lambda by r. So this is the electric field, and these are the directions of electric field. Next one. So far we have taken a point where we have to calculate the electric field is symmetric. Now, if the point is not symmetric, then how to calculate? So, this is a rod. This rod of length L is uniformly charged with positive charge, and the total charge is Q on it, and the length of the conductor is L. So, here at point P, which is at R distance, here this is the point P. There we have to find the electric field. Then what to do? We have to join this point P to the either ends of the rod. This angle is theta 1, and this angle is theta 2. So this is theta 1 and theta 2. These are the angles. This is the point P. Here the electric field direction. This is the y component of the electric field. That means perpendicular component, perpendicular to the conducting, perpendicular to the rod. And this is the direction of parallel. That means x component of the electric field. The x component of electric field is given as k lambda by r cos theta 2 minus cos theta 1, and y component of electric field, that is perpendicular direction to this rod, that is k lambda by r sin theta 1 plus sin theta 2. We can take this point anywhere unsymmetrically. So let us take this point like this. This is a conductor, a rod uniformly charged. The point we have taken here like this. So I will extend like this. Now just like this, we have to join this end. So from this vertical it is making angle theta 1, and with this end it is making theta 2. Here this is the perpendicular component of electric field. This is parallel component of electric field. So the values. Here one point you have to remember, this theta 1 having negative value. So here the x component Ex is equal to k lambda by r cos theta 1 plus cos theta 2. See here the values add up, that's why it came positive, and Ey is equal to k lambda by r sin theta 2 minus sin theta 1. So like this we can remember this formula. So these formula what we have discussed in this video enough for a NEET examination. If any one of you want to know elaborate discussions on finding electric field in some more cases, you can visit Target JEE videos. There we discuss. Those points are very important for JEE examination. But nowadays some JEE questions also appearing in NEET question paper. So it is better after completing all these points, and after learning these points, after practicing these problems, you can visit Target JEE videos also. So you can have some more points there on calculating electric field. Thank you.